Okay, welcome to lesson 7.5. Today we're going to be learning how to take what we have learned in the first 4 lessons of this unit, which is finding the slope of the tangent line using our derivatives, and then use that information to then write the equation of the tangent line. And again, this will be really helpful when you get to calculus next year. So to find the equation of a tangent line, I'm going to have to accomplish a couple of things. First, we have to find the y value of the point on the graph, and we're going to do that by substituting in the given x value into the original equation, right? So it's the point that we're given into the original equation. Then we're going to find the derivative, okay? And then use the derivative to find the slope of the tangent graph, or the slope of the tangent line. And then finally, we're going to use that to then write the equation of a line. We can use point slope form. You can use y equals mx plus b. I find that's a little more work. If we use point slope form, we have the point and we have a slope. So all we need to do is plug it in, and then we're going to leave it in that form. So let's go ahead and work through this process. All right, first of all, we'll do the 4 steps that we have here in order. So I actually put them in a different order that I think might work out a little bit better. No, I didn't. I'm going to still do these in the same order. So ignore the fact that this is A, B, C, and D. This would be step 2. This would be step 1. This would be step 3. And then this would be step 4. So step 1 is to find the point on the curve where x equals 1. So where x is equal to 1, we have this point right here. Now I know it looks like that's a y value of -2, but let's actually verify that. So we're going to find f of 1. That means plug in 1 into the original expression. So the original expression is here, okay? So that would be 1 squared minus 1 minus 2. And that gives us 1 minus 1, which is 0. So we get -2. So what I know is that this is the point 1, -2. That's really important for when we go to actually write the equation of the line. Second, we're going to find the derivative of f of x. So we do that using our power rule. And I think this one's a pretty easy one to do out of the ones that we did the last time. This is the easiest type. It's just a regular old polynomial. We can apply our power rule. So our power rule says we'll take the power, multiply it by the coefficient of x, and then reduce the power by 1. So the derivative of f of x is going to be 2x, and then minus 1, because this is a 1 right here. Step 3, find the slope of the tangent line at x equals 1. So this is where you take your derivative. So let me write that here. And we plug in 1. So we're going to find the derivative at 1. So that means we'll take 2 times 1, subtract 1. So that ends up being just 1. So now I know the slope of the tangent line is 1. And that's at the point 1, -2. And then finally, we're going to write our equation of our line. So the equation of the line, we're writing the equation of the tangent line. We're trying to figure out what the equation of that line would be. So what I'll do is I have point slope form of the equation written above. I want to make a slight adjustment to that. Let's just make it y minus y1 and x minus x1. It just works out a little bit easier for us since we only have 1 point. So I'm going to take y minus y1 equals m times x minus x1. And this should be familiar. I think we talked a little bit about this at the beginning of the year. Not much, very briefly. X1 and y1 are just any point on the line. So in this situation, x1 and y1 is represented by the point 1, -2. So this is our x1, this is our y1. M is just our slope, and we have that as 1. So what I'm going to do is plug in y1, m, and x1 into this equation. So I will get y minus y1, which I can see is -2. So y minus y1, y minus -2 is plus 2. equals m, which I said is 1, times x minus x1, and that is just the x coordinate of the point. So 1 minus 1, or x minus 1. I can simplify this a little bit and just make it y plus 2 equals x minus 1. You can get rid of the 1. You could even get rid of the parentheses here if you wanted to and just make it this. I would accept really any of those as a variation. This is fine. I do not need you to write this in slope-intercept form. I don't need you to write it in standard form. I just want you to write the equation of the line. In fact, I want you to keep it in point-slope form. I don't want you to change it because then we'll all have the same equation. All right, so let's try example 2. Now, I don't have the steps written out for you, but I'll go through them just like we did on the previous side. So step 1 is using the x value to find the actual ordered pair. All right, so we're going to take f of 1 in, negative 1 in this case. So that's 4 times negative 1 cubed minus 5 times negative 1 plus 3. And that ends up being negative 4 plus 5 plus 3. And that's going to be just 4. So what I know is that my point that I'm writing my line at is the point negative 1, 4. Now that's going to be my x1, y1 a little bit later. Step 2 is find the derivative. Okay, so I'm going to find the derivative for my function. Using the power rule, I take that 3, multiply it by 4. That gives me 12. And then I reduce the power on x cubed by 1, so I get x squared. And I continue that practice. Now, the next term I see is just my linear term. So I know my slope is just going to be negative 5, and then I'm done. Step 3 is to use that same x value we used before and now plug it into the derivative. So we're finding the slope of the tangent line at negative 1. So that ends up being 12 minus 5, which is 7. And remember, this is your slope of the tangent line at negative 1, 4. And then the last step is to write your equation. Okay, so again, using y minus y1 equals m times x minus x1. I'm just going to plug in what I found. And I go back here and highlight the things that I have found. So I know that x1 and y1, we found those, and I know that this is m. All right, let's go ahead and plug it in. So y minus y1, y minus 4, that's what I found there, equals m, which is 7, times x minus x1, which is negative 1, so that'll be plus 1. And then that's my equation. I do not need to do anything to simplify it. I'm going to leave it in point-slope form because that's the easiest form right now for us to look at. Okay, let's go through this process one more time together here. So first, I need to find what f of whatever my x value, actually, let's be careful what this is telling us, okay? So this is actually telling us this time that the derivative of f of x is equal to 4. So what we're given is that the slope of the tangent line is 4. Now that's interesting. Okay, so what we know is m. We still have to figure out what the point is. Okay, we still have to know what x1, y1 is. So how are we going to do that? Well, let's work backwards for a moment. I have the function. Can I find the derivative? So what is step 2 in this situation? Step 2 is find the derivative of f of x. So let me go back up here and find the derivative. So using the power rule, I'm going to get 10x minus 16. Now, I'm told, so in step 3, if we plugged in our x value, we get that it's going to end up being 4. We get that the slope of the tangent line ends up being 4 when we plug in our x value. We can use those two things in conjunction with each other to figure out what our x value was. right? So let's notice that those two things are both equal to f prime of x. So we can now find x by setting those two things equal to each other and solving that equation for x. Now I would go back and do step 1. Okay, and the reason for that is I didn't know what the x value was to start with. So I had to find a way to find that first. Well, now that I know what the x value is, I can plug that back into my original function. So I would have 5 times 2 squared minus 16 times 2 plus 12. And we get, that's 4, that's 20, minus 32 plus 12. And that's just going to be 0. So what I know is that when x is 2, y is 0. There's my x1, y1. Remember, our ultimate goal is to get to this final step, which is write the equation in point-slope form. And we can't do that unless we have these three things, y1, m, and x1. We started out knowing basically what m is. And we had to use that information to figure out what our ordered pair was by finding x and y. Now that I know all of that, I can write my equation. So I would have y minus y1, which in our case is 0, equals the slope, which is what we were given to start with, right? We were given the slope, times x minus x1. Well, in this case, x1 is 2. And we've got our equation. Now, I could write this a little bit nicer because y minus 0 is just y. But that's all I'm going to do here. And then that's my equation. So it's important to pay attention to what you're being given in the beginning. All right, the last one's going to be a little bit of a challenge, but we can do it. For f of x, let's find the equation of the tangent line at x equals 4. Okay, so just like we're given the x value this time, we're given the place on the graph where we're going to find the tangent line. So we're going to go through our steps in the order that we talked about on the front of the paper here. So the first thing I'm going to do is find f of 4. In other words, I'm going to plug in 4 into my function. So 16 divided by 4 minus 8 times the square root of 4. And then I've just got to simplify. So 16 divided by 4 is 4. Minus, that would be 8 times 2, so 4 minus 16, and we get negative 12. And remember, what that's giving us is the ordered pair. Our ordered pair is 4, negative 12. That is my x1, y1. Now, step 2 is to find the derivative. Well, before we find the derivative, let me back up for a second. We talked about this last time. It might be helpful to just rewrite the equation. So let me take a moment and rewrite my equation so that I have exponents and not these weird things happening, right? So 16 divided by x, that can be rewritten as 16 times x to the negative 1 power minus 8 times the square root of x can be written as x to the 1/2 power. And now I'm going to go ahead, I'll use a different color for the derivative, and find the derivative of f of x. So I multiply the negative 1 times the 16. That gives me the new coefficient. And then I reduce that power by 1. So I'm going to do negative 1 minus 1, which is negative 2. And then minus 1/2 times negative 8 is negative 4. And then reduce that power by 1. I get x to the negative 1/2. And then I'm just going to use my rules to rewrite things in the proper order. So to rewrite, I would be able to say negative 16 over x squared, and then minus, so I could write that as 4 over x to the 1/2 power. Then I could go one step further and say negative 16 over x squared minus 4 over the square root of x. And now I've rewritten it in a form that's a little bit easier to evaluate. If I ask you to plug in x here, you're going to have a hard time evaluating it. But plugging in x here makes it a little bit easier. So step 3 in our process is to find the slope of the tangent line at the point that we're given. So at x equals 4. So now it just means I'm going to plug in 4 into my derivative. Okay, and then I'm going to evaluate. So I get negative 16 over 16 minus 4 over 2. So that's going to be negative 1 minus 1/2, and we get negative 3/2. So this is your slope of the tangent line at the point for negative 12. And then the last thing we do is rewrite our equation. So y minus y1 equals m times x minus x1, and we plug in what we have found. So we know x1 is 4, y1 is negative 12, and we found that the slope is negative 3/2. So I can begin to write my equation. Y minus y1, so y minus negative 12 is plus 12, equals my slope, which I found is negative 3/2, times x minus x1, which is just 4. And then that's my equation. And like I said, we don't need to simplify that at all. So, like I said, today is just kind of putting together everything we've done over the course of the last couple lessons, and also combining that with some things that you did in Algebra 1, maybe in Algebra 2, beginning of this year, where we're writing the equation of a line. All right, I'll see you in class. Let me know if you have any questions.